Okay, so based on the properties that we learned about the antiderivatives, now we want to do the find antiderivatives of more general function. Here, for example, this is sums and differences of different functions. So I have x to the power 3 minus 4 times x to the power 2 minus root x is the same thing as x to the power half plus 5. If I want to find antiderivative, I know that sums of antiderivatives or differences of antiderivatives is antiderivatives of sums. So here that means that I can find antiderivative of each one. Antiderivative of x to the power n is x to the power n plus 1 over n plus 1. So here n is 3 for this term. It will be x to the power 3 plus 1 over 3 plus 1 minus 4. That's the constant multiple rule. X to the power 2. The antiderivative of x to the power 2 is x to the power 2 plus 1 over 2 plus 1 minus x to the power half, x to the power half plus 1 over half plus 1. And antiderivative of 5 is 5x plus c. And simplify those ones. Definitely you can do x4 over 4 minus x 4x x cubed over 3 minus x to the power 3 over 2 over 3 over 2, which will be 2 over 3 here, plus 5x plus c. How about this one? Okay, so these ones, as well as previous example, you can write as sums of powers of x. The third root in the denominator is x to the power 1 over 3, and I take that to the numerator, right? X to the power negative 1 over 3 plus fifth root of x is x to the power 1 over 5 plus 3. Now find the antiderivative of each term and then add them. So here is x to the power negative 1 over 3 plus 1 over negative 1 over 3 plus 1 plus x to the power 1 over 5 plus 1 over 1 over 5 plus 1 plus 3. Antiderivative of 3 is 3x, and we need to put plus c always when we're trying to work with the antiderivatives. So negative 1 over 3 plus 1 is 2 over 3, and the inverse of that is 3 over 2x to the power 2 over 3 plus this will be 5x to the power 6 over 5 over 6 plus 3x plus c, and that's the antiderivative of the given function. How about this one? Well, this is the quotient of two functions. Antiderivatives of quotients are not quotients of antiderivatives. That's same as the rule is not easy for the antiderivatives, the quotients. But in this specific case, what we can do, we can separate the domain for each part, and we get this. Yeah, and then simplify this with 2x cubed minus 3x plus 3 over x plus, oh, that's it. Now I have to find the antiderivative of each term and add them. So the antiderivative of the function is equal to 2 is constant, x to the power 3 plus 1 over 3 plus 1 minus 3 x to the power, so x is x to the power 1, yes? So n is 1, so x to the power n plus 1 over n plus 1 plus, this is 3 over x, so it is 3 times 1 over x. 3 is constant, so constant multiple says that you just need to find the antiderivative of 1 over x and then multiply it by 3. And we know that antiderivative of 1 over x is ln x, or ln of absolute value of x plus c. And that will give you what we have. Okay, so let me do that. X cubed over 2, that 2 plus, and 4 will cancel. This will be 3x squared over 2 plus ln of absolute value of x plus c. For the last example, we have x to the power 5 minus 4x to the power 2. We don't have any rule for antiderivatives of powers of functions, but in this specific case, I can expand it first. So x5, first one squared plus 2 times first one times second one, plus the second one squared, and that will give me x to the power 10 plus minus 8 x to the power 6 plus 16x squared. Now, if you look at this guy, this is just a simple polynomial, and antiderivative will be sums of the antiderivative of each one. So the first one, x to the power 10 plus 1 over 10 plus 1 minus 8 x to the power 6 plus 1 over 6 plus 1 plus 16 times x to the power 2 plus 1 over 2 plus 1 plus c. Well, the simplification is the rest is easy. X to the power 11 over 11 minus 8x to the power 7 over 7 plus 16x cubed over 3 plus c is very important, and that is the antiderivative of the given function. Oh, I could stop the recording myself.